for the extraction of metals. First of all, we will check the samples. Okay, which samples is going to have much concentration of the metals. Like for example, if you are going to extract the calcium, then you will find that calcium carbonate. Where is calcium carbonate? From calcium carbonate, you can extract the metals. Okay, so you went to the means you will just take the samples with, or the ores or the minerals that is going to have much concentration of calcium. Okay, and then you start refining, you start removing of impurities from it. There are certain steps that are being followed. Okay, during the extractions of metals. So all that study, all that steps that you study, that comes under the study of metallurgy. So what is metallurgy? Metallurgy is the branch of science that deals with the study of extraction of metals. Okay, from the earth crust. Okay, you understood? Understood?
So
Everybody?
meteorology or meteorology?
Metallurgy.
Meteorology.
Okay, now talking about this one is, now you know that metals, if we are extracting the metal, we are just studying about the metallurgy. So first of all, the very important is that when we are extracting the metals, okay, when we are extracting the metals, there are some metals that exist in the free state, native state, and there are some metals that exist in the combined state. They do not exist in the free state. For example, if you are having gold, the gold exists in the earth crust in the native state. You just take it out, you just purify it, and this is now gold. But if you are extracting, if you are extracting the calcium, so you have to extract the calcium from calcium carbonate. For that, you have to heat the calcium carbonate, then it will be converted into calcium oxide. Then you have to remove the calcium oxygen from the oxide, then you will get the calcium pure metal. So it is not easy task. Okay, so this is called combined state. So some metal exists in the pure state and some metal exists in the combined state. Okay, you understood. So if the metal exists in the native or free state, we call it native state or free state, like gold, silver, platinum. Sometimes copper also exists. Okay, so we're talking about sometime copper and silvers also exist in the pure state. Okay, and they also exist in the combined state also. But gold and platinum, this is PT is platinum. Okay, so note it down. And native state means combined, that metals exist in the earth crust in the form of a stable compound that is called uh, okay, note it down. Combined state. Note it fast. If they exist in the stable compound, the form of stable compound, like we have Al2O3, ZNS, AGS, PBO. So this is the combined state. Done? Noted?
No, sir.
Noted fast. Is there is Jobita in the class? Jobita? Jobita is not here. Done? Should I move forward?
So 1 second.
So What's this bauxite?
Bauxite. Bauxite is an ore of aluminium. Okay, we're going to discuss this one. It is Al2O3 dot 2H2O. And this is Bauxite. 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 Bauxite.
Yes, sir.
Done, everybody?
Yes, sir.
Okay. So let's move further. Now you know that if you have some metals exist. Now talking about this one, that the next step that you are going to extract the metals from the earth crust. Okay. Yes, you went to metal. You find a sample A, another sample is B. In sample A, you find that if you are extracting the metal, then it is very cost effective. Means it is not cost effective. It is very costly. Okay, it is costly and taking much time. Taking much time. Okay, and here in sample B, you find that it is we can say that cheaper or economical, okay, and convenient, easy, okay, easy to extract out metal from B. So which one we would choose the sample, A or B, for extracting the metals?
B.
B. Yeah, you will choose simple. Definitely, you will choose B because B is giving you means the metals at same cost. It means the cost is cheaper and easy. So you will choose B. Why you will choose A to extract or metal? Because means, for example, need to if you need to collect the water, okay, for your use, you can collect the water by using AC. That is taking means the AC, you know that water comes out from the AC drop by drop. Okay, so you can collect the water from there. Okay, or you will use the water tap by using a pump. Okay, so which do you think is cheaper? You know that the whole day and night you need to run your AC for just filling one bucket of water, so it is taking much time. Okay, and it will use much electricity for giving you one bucket of water from this, and then after you need to purify that water also, which is not usable form. But if you have invested in the means if you are using the water pump, and you need to plug switch on the, and you will get to, in 1 minute you will get one bucket of water. And it will not use such much electricity. So you will definitely choose B na, means the tap water, instead of using that AC, okay, for collecting the one bucket of water. Okay, understood?
Yes, sir. Yes,
So
sir.
this is a simple case for understanding that. But still, if I'm talking about that, if you are collecting the water and AC can gives you the water in tap, so both are the source of water. Na? Okay, but the good source of water is tap, not your AC, the water coming out from your AC. So we can say that if both the source can give you the water, they are considered to be as minerals. What is mineral? Mineral is, we can say that there are two types of substance. Those elements or compound that we are talking about, elements or compound that exist naturally in earth crust. If there is something that exists naturally in earth crust, that exists naturally in earth crust, okay, we called it minerals. Okay, whether it is a for example, if I'm having soil, so if you start extracting the soil with calcium from the soil, that it will be more uh, costly, or it will take much time. But if you start extracting the calcium from calcium carbonate, so it will be cheaper for you, because calcium carbonate consists of much percentage of calcium. Okay, you understood what I'm going, but both soil, because soil is also having calcium carbonate is going to have calcium, so we'll say that both soil and calcium carbonate both are minerals, because they consist of elements or compound. But the minerals from which we can extract the uh, metals at cheaper rate, easily, conveniently, with less effort, less time, we will consider to be as ore. So calcium carbonate is considered as here as an ore, because it is giving you calcium at lower price, lower effort, lesser time, and this and the sand will be, or the sand or the soil will not be considered as an ore because it is taking much time. So what is a mineral? Mineral, but both sand, or we can say soil, and calcium carbonate, both are minerals, but both are not ores. Ores is only that mineral that can give you the metals at lower price. Okay, so what is an ore? Ores are those minerals from which metal can be extracted out easily and economically. Okay, only those minerals. Got it? For example, let me explain you with an example. For example, if you have Al2O3 dot 2H2O, this is bauxite ore. This is bauxite. And the one is Al2O3 dot 2H2O dot 2SiO2. This one is China clay. China clay. Both are having aluminium, but this is more cost effective. This is taking much time. China clay is taking much time. So it is not an ore of aluminium. Aluminium. And this is bauxite is taking less time, less effort, economical. So it is, we can say that uh, it is an ore of aluminium. You understood? It is an ore of aluminium. But here you can see that both are minerals. Both are minerals. So all ores are mineral. This is also a mineral. But all mineral, this is a mineral, but not an ore. So all ores are mineral, but all minerals are not ores. You understood? Everybody in the class?
Yes, sir.
Okay. So know the definition of ore and minerals.
So the mineral, so ores what? Ores
That mineral,
what?
from which you can extract the metals economically at lower price. Okay. And minerals is
Can
anything
I
that
just
can,
say, yeah, ores are like,
ores are like we have
I'm trying
a,
to say.
let me explain you that. For example, if you need to extract the metals, iron metals, so you need Fe2O3, and you have FeS, you have Fe3O4. So this is an ore of iron because you can easily extract the iron metal from this one. But if you start extracting the iron from this soil, that is just a sand, silicate is present in this one, so you cannot extract. So this is silicate that we have in the sand, it is not having much percentage of iron. So it will have iron, but will having very less amount. So this will not be considered as, sand
So
will not be
ores are
considered as.
minerals. So then ores are minerals that we can extract. Ores are minerals that we can extract economically at lower price, right?
Yeah, ores, there is
Okay.
a definition. There's
Because I had a hard time saying
those minerals from which metal can be extracted out easily and economically are called ores. Note it down.
it. Okay.
Done? Note it fast.
Then sir.
Done, everybody in the class?
Yes, sir.
Okay, let's move further. Now, talking about this one, now you have decided that which are ores. For examples, if you need to extract out calcium, so you have chosen that CaCO3 will be the best thing from which we can extract the calcium metals. Similarly, if you need to extract out sodium, then NaCl is the best thing, that substance that can, from which where you can extract out the sodium. For example, for iron you have chosen Fe3, Fe2O3. Okay, for lead you have chosen PBS. For zinc you have chosen ZNS. Okay, so these are the ores. You have chosen that one. For aluminium, you have chosen Al2O3 dot 2H2. Okay, 2H2O. So these are the ores you have chosen. Now, after you have chosen the ore, you have decided, you have found. Now you will went to the site where these substance, or means the rock or the earth crust, is going to have much percentage of these. For example, if you need to extract calcium metals, so where you will start extracting the calcium where calcium carbonate is more. So you went to that site. Now you start digging. What you will do, you start there are several steps now. Till the purification of metal, there are several steps. What you will do, you will start, went to the site, you will take the samples, and then this next one is, then you will start taking out the big hump of that rock. Okay, and then you will start crushing them into powder. Okay, so first of all, what are the steps here? Steps for extracting the metals. The first step is selection of ore. Selection of ore. The second one is crushing. Crushing of or means, or crushing or hammering, you can say. And the third one is enrichment. Enrichment or concentration of ore, or concentration of ore. Concentration of ore. What do you mean by the word concentration or enrichment of ore? We can say that removing of impurities, removing of gang means like silicate, like sand that is present in the, okay. So this is gang, removal of gang or removing of gang. So the next step is enrichment of ore. Now you have crushed it. Now the third step is enrichment of ore. What do you mean by the word enrichment of ore? The removal of impurities. For example, if you are crushing the calcium carbonate, it does not mean that a stone, if you are having a calcium carbonate, is going to have 100% calcium carbonate. No, the stone must have some sand, some impurities, some silicate ion, some other substance also. It will have much percentage of calcium carbonate, but it is not, we cannot say that it is 100% pure calcium carbonate. If you crush it, every particle will be calcium carbonate. It will consist of sand particles also. Okay. So what we need to do is, we need to remove this sand from that one. Okay. You understood? What we need to do? Tell me. We need to remove the sand, and this is called enrichment or concentration of ore. So we have four types of ores. Generally, we have the carbonate ores. Carbonate ores. The second one is the second one is carbonate ore, sulfide ore, sulfide ore. The third one is we have sulfide ore, calcium carbonate, and we have halide ore, halide ore. And the fourth one we have is oxide ore. Let me write here oxide ore. Oxide ore, and then last one is halide ore. Let me discuss each and every one. Okay. If I'm talking about this carbonate ore, the word carbonate means that it must have CO3 group with it. Like for example, calcium carbonate, like we have zinc carbonate. Okay, like we have sodium carbonate. So these are the carbonate ores. Okay. Sulfide ore means it must have sulfur with it, like we have ZNS, like we have PBS, etc. Lead sulfide. Oxide ore means it must have only oxygen, Al2O3, okay, Fe3O4, okay, etc. ZNO. And halide means it must have halogens. What is halogen? The 17th group of the periodic table. You have seen the periodic table, there are groups 1, 2, 3, 17 groups are there. So in the second last group, that's called the 17th, and the last one is 18th. In the 17th group element is called the halogen group. Halogen, halogen, halogen. Okay. And this consists of fluorine, chlorine, bromine, iodine. So if there is an element, any one of the element is present with the metals, then we will consider it as halide. For example, sodium chloride. Chlorine is halogen, so it is considered to be as halide. If it is hydrogens, if it is anything which is either of any element of this one, like we have PbI2. So this is halide. Okay, are you understood? Now you understood, everybody?
Yes, sir.
So there are different methods that we generally use for the enrichment of this ores. Generally, the oxide and carbonate ores. Let me oxide and carbonate ores are enriched by carbonate, and oxides ore are enriched by what? By a special method that is called gravity separation. Gravity separation and hydraulic washing. Hydraulic washing, gravity separation or hydraulic washing. Understood? Note it down. The first method for the enrichment is gravity separation or hydraulic washing. That we are just studying enrichment of ore. Enrichment of ore. Note it fast.
Sir, what do we mean by gravity separation?
Let me explain you this one. Actually, these topics are the detailed study of this one.
What, sir?
So actually, this is not in the this time. This has been removed. Means the explanation of each and every gravity separation, hydraulic washing is being removed. So I can explain you that what is gravity separation actually. So let me explain you that what is gravity separation. It is not, means question is not being asked. Okay, on this one, let me explain that in gravity separation, what we does here is we have uh ores, and it is mixed with some sand particles, means some amount of sand. So we just put it in some pits, like structures like this, and we just pass a stream over it. Hydraulic washing means water washing with water. So because the ore particles are heavier, so they will settle in the pit, in these pits, but the impurities, the sand particle which are lighter in weight, can easily flow with the water stream. So this pit is collecting the pure ore, and this sand particles are being removed, okay, with this water stream. So this is hydraulic washing. You understood?
Yes, sir.
Understood? Everyone? Understood, everyone? That what is hydraulic washing? That here the water particles. Ashit, you want to leave? Okay, you can leave. Is there Madhiya in the class? Okay. Okay, now moving to the next part here is the next method is Froth flotation method, that is also used for the enrichment of ore, and we can talk about this one. Okay, Froth flotation method. Froth flotation Froth flotation method. Okay, this is used for the enrichment of which type of ore? Only sulfide ore. So suitable for enrichment of which type of ore? Tell me. Sulfide ore. Note it down. Growth for next method is it is suitable. Growth flotation method is suitable for the enrichment of sulfide ore. Okay, means removal of gangue from the sulfide ore. The next one is magnetic separation. Magnetic separation. And how can you separate? Like for example, if you are having a roller like this, let me first note this one. Noted this one. Amar,
Yes, I'm doing so.
Ashid is asking me to leave. Yes, you can leave if you want to leave. For the prayer.
Sir, this topic is from which chapter?
This topic is from metals and non-metals.
Um,
The next one is magnetic separation. How can you separate the magnetic means? Actually, you have a roller like this and another roller. Okay, one is magnetic roller. One is magnetic roller and the one is non-magnetic roller. Okay, this one is magnetic roller. Magnetic roller. And this one is non-magnetic roller. So we have this conveyor belt. Okay. So here we have the ores that is consisting of impurities. Okay. So when this belt goes and this is revolving like this. Okay. So the substance that is going to have that does not attract with the magnet, it will falls here. It will falls here like this and will form a separate heat. But the substance that is going to have, we can say that if it is being attracted with the magnet, that this is being attracted with the magnet, so it will keep on attracted with the magnet till here, and till the conveyor belt loses its magnetic field here, so it will separate it here. Okay, got it? You understood? So what this is how magnetic impurities can be separated from the non-magnetic impurities or non-magnetic substance. Okay, so now you understood. So magnetic ore can be separated from non-magnetic impurities. Non-magnetic impurities. Okay, got it? By magnetic separation. You understood?
yes, sir.
Understood, everyone?
Yes, sir.
Okay. So let's move further. So let's now we have what we have done here till yet. We have just separated the metals from their sorry, we have just separated the ores from their impurities. Okay, impurities has been removed. Now we have concentrated ore. Concentrated ore means if we take the samples of that ore or the powder of the sample, then most of the particles will be of ore, not of impurities. Okay, but before we were when we had when it is on not concentrated, then if we take the sample, it is along with ore, there are some impurities, sand particles also there. Okay, so we have just removed the sand particle from this one. Okay, got it? You understood?
Yes, sir.
Now moving to the next point here is after the enrichment of ore, uh, what we will do? The next step is bringing the ore in suitable form. Bringing the ore in suitable form. And why there is a need to bring the ore in suitable and what is this? For example, this is for the ores that is carbonate ore and sulfide ore write it carbonate ore are being converted into their oxide form. Like for example, if you have calcium carbonate and if you have calcium oxide, if I ask you that from which, either with from calcium carbonate or calcium oxide, which you can easily extract the calcium. So it is easier to extract the calcium from calcium oxide rather than calcium carbonate. Okay, so you can extract the metal from this one, not from calcium carbonate. Okay, it is easier for here. And if you take the another one is like if you have zinc sulfide and you have zinc oxide, if I ask you that from which you can extract the metal more economically, more conveniently, so it is their oxide form. So what we do is we are just converting the carbonate form into their oxide form, and carbonate ore into their oxide ore, and the sulfide ore into their oxide form. And why we are doing this? Because it is easier to extract metal from their oxide form rather than their carbonate and oxide form. You understood? Understood?
Yes, sir.
So, what we called it, this is calcination and roasting. Let me explain you what is calcination and roasting here. Okay. So if I talk you about the calcination, what is calcination? In this process, carbonate ores are heated in the absence of air. Carbonates ore are heated in the absence of air. This calcination is done to bring the carbonate ore into their oxide form. Okay. And you know that carbonate, if I talk about this carbonate, like for example, if I'm having calcium carbonate, and if you are converting it calcium oxide plus CO2, you know that this is balanced. 3 oxygen, 1 carbon here, and 1 calcium. So it is balanced. So no external oxygen is being required because carbonate group has sufficient amount of oxygen to convert it into their oxide form. But if I ask you that this is zinc sulfide, if you don't need to convert it ZNO, will you be able to convert this one? Will you be able to convert this zinc sulfide to ZNO without the external supply of oxygen? Yes, Amma, you tell me.
Yes.
No, we can't because there is no. If we don't have the external oxygen, how can you convert this to ZNO? There is no oxygen, so you have to give the oxygen in this case. So this is called roasting. In roasting, sulfide ores are heated in the presence of oxygen, in the presence of oxygen or presence of air. But in the calcination, the carbonates ore are heated in the absence of oxygen. Absence why? Because there is already oxygen present in the carbonate group. Okay, understood, Madiha?
So so the calcium
Yes, sir.
it's heated in the with what? It's heated without like
Yes,
without the presence of air.
yes, we just put the calcium carbonate in a closed chamber. There is no oxygen supply is there. Okay, so we heat it, then it will get converted into calcium oxide. Okay, got it?
Okay. But for
Uh,
this
yeah,
ZNS, we have to
Yes, if it is sulfide ore, then we have to give the oxygen,
Okay.
because it is sulfide now. How can you convert it into ZNO, because there is no oxygen here? So you have to give the oxygen and will get converted into sulfur dioxide. Okay. So let's me talk further here is you can balance this one, right? You can balance this one. Okay, balancing here issue here. Okay, not talking about this one, that what the other advantage also. First of all, the first advantage is that of calcination is that because it help in the conversion of carbonate ore into the oxide form. So we can easily extract the metal from their oxide form. The second one is that it also help in removing the volatile impurities. For example, if it has some volatile impurities, volatile means that melts at low temperature, because you heat it at very high temperature, it is 900 degrees Celsius for calcium carbonate. So if there is some volatile impurities that can melt at 100, 200 or 300 degrees Celsius temperature, so it can be easily separated out in the form of fluid. Okay. And metals and ore is separated along with it. Okay. You understood? For example, if we have like this we have a tilted form, and like one side is so if we have ore here and we start heating it here from here, okay, in a closed chamber, if it is calcination, and then if there is volatile impurities, then it will get melted and will be separated out. Okay, got it? Got it?
Yes, sir.
Okay. So let's you write it down. Calcination and roasting. Note it fast.
Sir, in roasting of ZNS, uh, the SO2 will be in the stage of gas or solid
Is in gas.
liquid. Okay, sir.
Note it fast. Done. Noted.
No, sir.
Noted fast. Done?
Yes.
Everybody done? Okay. So let's take some question from this topic that we have studied till yet. Okay, and rest of the part of this chapter we're going to discuss in the next class because some of the students have not joined because of their exams. The next part is very important. Okay, so let's have some question on this topic. Do question number 65. What is the answer? Two ores A and B are taken on heating. A gives carbon dioxide, where B gives SO2. Which steps would you take to convert them into metals? Tell me.
Um,
A and B on heating gives A gives carbon dioxide, where gives. Which steps will you take to convert them into metals? First, you will take the calcination and roasting, and that rest for
uh,
removing their oxygen. We will discuss this one in the next class. Okay. Uh, because reduction we have not studied till yet. Question number 50. Give the reaction involved during the extraction of zinc from its ore by roasting ore and calcination of zinc ore. Question number 55. What should be the answer for this question? Hmm?
ZNS plus O2.
Yes, if you have roasting, that ZNS plus O2 will give
ZNO plus SO2.
ZNO plus SO2. Okay, and for calcination of zinc ore, if you are doing calcination of, so you must,
CaCO3
no,
by
gas.
heating.
It is zinc ore, so
Oh,
it will
okay,
be
okay,
zinc
sorry,
carbonate.
sorry.
So if you heat it, you also heat it, then you will get ZNO plus
Then,
CO2. CO2, okay?
yes,
You understood? Everybody in the class, dear students, you understood? Jaslyn, Madiha, Kumar,
Yes, sir.
So your voice is breaking.
Yes, sir.
my voice is breaking.
Yeah, okay. Now it's fine, but previously it was breaking.
Okay, why didn't you tell me?
No, like when you just it started breaking, but then just after a few seconds, it went back normal.
Okay. So now,
if
do you think
his
that,
networks are not, yes.
okay. So if I'm talking give the reaction involved during the reactions, so this is for the roasting. If it is roasting is being done here, so if roasting is being done here, so we can say that it should be a sulfide ore, so ZNS. If calcination of zinc ore means it is zinc carbonate, and then it must not be oxygen. Okay. So this is question number 55. We have done this one. The next is question number 49. What happened when zinc carbonate is heated into in the absence of oxygen? Hmm? What would happen if zinc carbonate is heated in the absence of oxygen?
ZNO plus CO2.
ZNO plus CO2 will be formed. Yes. So this second part of this one we will study in the next class. Question number 39. Why should metals of sulfide and carbonate should be converted into the oxide form for the extraction of metals from them? Why we are converting the carbonate ore into the oxide form? Tell me.
To extract metal easily,
Yes, to extract metal.
efficiently.
Because it is easier to extract metal from their oxide form rather than their respective carbonate and sulfide form. Note the question and write the answer. Please note the question number 39. This is important question. Note the question. Write the answer. So here is the question, and why we are converting sulfide ore and carbonate ores into their oxide form. Answer is it is easiest to extract out metal from their oxide form rather than their carbonate and sulfide form. Note it first. Done.